Hello, I am Alexander, an embedded C++ developer at Droid Technologies. I specialize in firmware development for different microcontrollers such as bare metal or ARPOS-based. In this video, I will guide you through understanding how electromyography sensors work and explore the metrics that can be obtained from these sensors when connected to the arm. We will be using a PCB designed by our hardware engineer, which incorporates the following features. Input buffer based on an operational amplifier to provide high impedance for the electrodes. Differential amplifier for amplifying the signal from the electrodes. Hardware filters to eliminate high and low frequency noise. A microcontroller with an integrated 12-bit ADC, which is sufficient for EMG sensors. Electromyography is a diagnostic technique used to measure the electrical activity of muscles both at rest and during contraction. In our case, we attach the electrodes of EMG sensors to the hand to monitor muscle activity. By stimulating the muscles and recording their electrical signals, we can identify which specific muscle groups are being activated. Based on this information, we can determine appropriate actions. For example, this data can be used to control a bionic prosthetic, pinch or unpinch hand, or even move individual fingers, depending on the number of sensors and the algorithms employed. The EMG system typically involves 3 electrodes, 2 for differential signal measurement and 1 as a command or reference electrode. We connect 2 channels of electrodes to the hand and interface them with a PCB designed for measuring the EMG signal. Although our system is capable of supporting 8 EMG channels on the PCB, for the demonstration video we utilize only 2 channels. The EMG PCB is connected to a secondary PCB, which serves as a bridge converting the SPI interface to a USB connection. This setup allows us to run a custom test application for analyzing and processing the data. After connection the electrodes and all components, we launch the application to perform a simple test. The first measurement is taken while the hand is at rest, with no movement. In this state, the test application displays a plot without significant signal bursts. In the second test, we pinch our fingers together and observe the plot. The amplitude increases during the pinch and decreases back when the fingers are unclenched, providing clear feedback on muscle activity. Obtaining a high-quality signal from muscles using EMG sensor is a complex process. It requires extensive noise filtration both on the hardware and firmware levels, utilizing advanced algorithms to ensure accurate and reliable measurements. At Droid Technologies, we are here to assist you with your embedded design projects covering electronics, firmware, software, and mechanical design to ensure successful implementation and optimal results.